Good afternoon, folks. My name is Alison Wise. I'm going to talk today about something a little bit removed from some of the more technical presentations we've seen. I'm an economist and I'm a strategist. I've been in the Save the World industry since 1996. My background is when I was the first MBA that the National Renewable Energy Laboratory hired. I was the head strategist and headed up something called the Venture Capital Network, where we invited folks from the private sector to come and sample our wares, see if they wanted to spin anything off. And so I got to work with folks like John Moore, Elon Musk, other big names that I won't drop. But it gave me a purview of what was possible. And so when I left the lab, I started Wise Strategies, which is our consulting firm. I'm founder and principal, and been in existence since 2011. So I have tried as a strategist to ask the right questions to get the right answer. And the challenge has been finding the right question. And what I've come to at this stage in the exploration is that the Earth is a giant superorganism. And so our systems need to mimic organic systems. And what that means is that we've based our entire civilization on the idea, and most recently the last couple hundred years, looking at our systems as mechanical ones that mimic machine models, that we are somehow can take existence and frame it as if it's a set of interlocking parts and cogs and wheels. When actuality and reality, we need to look at the model as one of organic substance. In other words, we need to look at our systems not as mechanisms, but as systems that mimic what we see with billions of years of research and development in the natural world. One other conclusion at this point is that also, how we get from here to there is incredibly challenging, and that all of our systems are also based on a broken premise, which is that Darwin concluded that competition was the driver for our evolution. And actually, that was not what his whole research was about. It was actually about how competition was a node within a cooperative framework. And so, in other words, if you look at a forest, the current purview would see trees competing for water. Branches are competing with other branches for water in a tree, and that these trees are siloed within the forest, each trying to compete with one another for resources. When in actuality, the forest is itself an organism that's organized by mycelium, which is a fungus underneath the floor. And it balances and helps the forest cooperate and create a mechanism, again, the parlance is there, by which this is how nature has evolved life. And we were talking earlier about how all life is based on the sun. Well, these are our systems that we already have the research and development at our fingertips. We need to now access it. But how do we get to that innovation? How do we get to those kind of models? So what I'm going to talk about today is a little bit about one way in which we can try to move forward. So these are slides actually from back when I was at NREL 15 years ago. They're not very legible, but essentially what it shows is that right now, energy that drives the economy is extracted energy. And what that means is that, when we look at, and again, apologies, these are, you can't even see the dates, but you can see how economic development and activity tracks the price of crude oil. Petroleum expenditures is a percent of the gross domestic product in the U.S. and real oil price. So you can see the expenditures and oil prices as how it's driving economic development. If we look at an extractive economy, you see that it's diminishing returns. You have drilling and mining that is driving economic development locally, but you have declining oil and mineral resources. You have shrinking jobs, and so therefore prosperity ultimately long-term is also shrinking as well. If we flip that pyramid and we use ideas and innovation as the feedstock, as well, and we use these ideas to create new products and services, we have new economic opportunities, new jobs, and prosperity is then expanded. So talking about democratization of economic opportunity as it's driven by energy, we can see that if we use these premises and ask the right question, we can use innovation as the driver for economic development towards a global economy that can mimic natural systems. Natural systems are 100% energy efficient and 100% renewable. The key to how we get there is decentralization. The key to how we get there is not building new transmission and distribution lines for centralized generation. It is about changing our structures and strategies so that we are creating point of use energy, point of use agriculture, point of use economies, point of use finances, to where we are a mosaic as a human community that are bound by a cooperative model. So this all seems idealistic, and I realize that, but you have to ask the right question to get the right answer. And right now, we're increasingly understanding that value is determined by human activity and human engagement with our natural environment, human engagement with the natural world. And what we're increasingly seeing is that we need to shift from a linear mode of economic development, from an extractive source, to a circular economy. A circular economy is one in which it's ideally is 100% energy efficient, and it's driven by renewable, 100% renewable energy sources. So right now, we see models in economic development that vertically integrate our resources. So they mimic machine-like systems, and you have siloed modes of innovation. We need to transition this to horizontal modes of organization that mimic organic systems, circular modes of innovation, so that we see nothing lost and driven by a completely renewable source. So as one example, looking at vertical integration in the smart energy supply chains, you'll see that the way the bits and bytes currently being used are through physical supply chains in a linear perspective. Now, this creates great efficacy with regards to management systems. It's much easier to dictate one decision from the top down. And it's how we've seen our military work, it's how we've seen our corporations work. But in a futuristic way of looking at this landscape, we will increasingly see more horizontal integration modes. And entities like McKinsey and Company, big consulting firms, are already advising their clients to look at organic models and look at horizontal integration as a way of capturing more value within their supply chains, more value within their human capital. And so we're going from a linear way and a vertically integrated way to a circular way of organizing resources, human capital, and activity. So innovation infrastructure is a very pithy way of describing this. We often focus just on the technology. We have a lot of conversations about engineering from the technology perspective, and we use assumptions of a competitive landscape and a capitalist system that take into account that competition is the driver. What this leaves out is that not only even in the existing models, we need to look more at innovation and financing mechanisms that come from a decentralized perspective, but we also need to look at public policies that are going to drive this kind of activity and economic development. So right now, with regards to the utility industry, we have all the sectors that owned by one utility, regulated and vertically integrated, versus multiple competitive providers of supply, multiple competitive wholesale market makers that can essentially innovate technology in distributed generation, plus storage, plus intelligent microgrids. Innovations and policies that will break down the monopolistic structure of utilities and transition them to systems that can incorporate more competition. If deregulation in this slide, I'm going to get to another slide in which I'm going to qualify that slightly. We don't want to repeat an Enron. We don't want to repeat anarchy. I can talk about that later. But one of the ways in which we can address this is innovation in our financing mechanisms as well. So distributed ledger technologies are financing mechanisms that can be localized use. Now, as an aside, distributed ledger technologies also require a lot of data center activity, a lot of computational activity. So we need to make sure that the energy for that efficacy is from sources that are not going to add to our climate problem. Now, all of this is within the realm, and I said innovation infrastructure with regards to climate resilience. This decentralization is the way we get from here to there with regards to how we change all of our global systems so that they are more efficient, we're not right now watering daisies with fire hoses, right? We are incredibly inefficient. One way that we can shift that is by looking at decentralizing financing, having policies that promote the decentralization of our economic development, and policies that through the introduction of more competition radically will accelerate innovation. So why is this not working? And all right, so why now? So what we see here is that we have increasing development that, and again, I apologize for illegibility, but essentially what we see is past, present, and future of energy. Since 1,000 years ago, or rather, since 1900, 100 years ago, we've seen peaks in terms of the extractive energy technologies that we've implemented. We've now increased our renewable efficacy here, but there's this gap between what we're currently creating and what's possible. So again, within the context of asking the right question to get the right answer, right now we measure energy as a commodity. It's an extractive resource, but there's a lot of work, and recently Bob Ayers was a Nobel Prize nominee. He's recently passed away, but his research team was looking into measuring energy as a unit of work. And if you measure energy as a unit of work and not as a commodity, you're measuring the right thing. We have to measure to manage. And measuring as a unit of work means that you're actually measuring energy as a service now. And energy as a service, you're maximizing the value of its efficient use. So the system itself is now asking the right questions to get the right answer. So McKinsey, as I mentioned earlier, they're already looking at ways in which they can translate this hierarchical, vertically integrated approach to opportunity to a more organic, circular frame of reference. And what we see with regards to the productivity as it relates to looking at what's actually possible, a low energy future has our curve here. The projection of what we can actually consume is up here. So right here is a gap between where we want to be and where we're projected to go. And this gap can be addressed by smart policies and productive investments that are enabled by information communication technology, new materials, new technologies, and innovative behaviors. So, with regards to the frameworks, we've gone from a mechanistic way of looking at opportunity to a more organic one. So we're looking at the machine that is the biological entity, that it's just a system of cogs and wheels, to a systemic, integrated, synergistic system. On the left, obviously, is the mechanical view, and on the right is the organic one. So at a glance, we're looking at ways in which historically we've seen. I was, graduating from the B School program in late 1990s. I was talking to folks in the information industry about where they were going to be left out of the loop if they continued to see themselves just as a brick and mortar newspaper, that instead what they were really offering was information. And companies that glommed onto the idea that they were an information provider, not a newspaper seller, were ones that really capitalized on where we went as a society with regards to how our communications were structured. All of this was now based on the very new and nascent at the time web-based social media systems. And nature itself has an interesting circular system that mimics for our idea of circular economies. It efficiently forms, adjusts, consumes, grows, evolves life cycles with details beyond just seasonal change. And so what we're talking about now is not a top-down model. We're talking about each opportunity being equivalent to a grain of sand on a beach, and that we now have technologies that enable us to instead of pushing everyone towards one centralized opportunity, we can have technologies that help to lift each grain of sand. And what I mean by that is that we're going from automation to artificial intelligence. So the more we innovate capabilities into our infrastructure, the better our ability is to innovate at scale with ecosystem and intelligent design models that balance industry with planetary limits. create a system and infrastructure that can mimic the biological systems that have evolved over billions of years, and build circular systems that respect ecosystem limits to perpetuate climate resilience. And I talked a little bit about that already. So AI is biomimicry. Our brain, our mind, has evolved over billions of years of evolution. It is an organic structure. We are now creating artificial intelligence based on the human brain, but that is a mechanism that has evolved already over those billions of years. So when we talk about AI and we talk about all the component parts, this is already a biomimicry system. It's a model of the neurons in a biological brain. Already we see artificial intelligence as it applies to the energy industry. I think that this visual is self-explanatory. You see that we have optimized market operation and design by employing these intelligence so that we are not, again, watering daisies with fire hoses. We are able to address and allocate energies at where it's needed, when it's needed. So already, again, we see biomimicry in systems. Japan, this is a model. The Tokyo Rail actually has been developed to mimic the development of slime molds. Each of the nodes that you see there are stops on the rail system. And by designing it as slime molds grow, it's an efficient way of them understanding where they need to go and how they need to go. And they've had this in place now put this in place now as they were building the system with engineers that were cognizant of the benefits of that. So when we talk about decentralizing energy, instead of talking about how we can build out transmission and distribution systems, we need to think about how we decentralize them. And so what that means is introducing micro-utilities that are a bundled opportunity of mobile storage, EV infrastructure, microgrids, intelligent grids, renewable energy generation, and using that in an integrated solution way. So in order for this to grow, micro-utilities need to be able to be playing within a market that has regulations to address that. The market will play by the rules, but the rules have to be set right. So instead of building new interconnections, we need to build out the ability to create microgrids where we need them, point of use. Oops, pardon. So looking back, I wrote a paper at Emerald that was looking at, and this was again 15 years ago, looking at lessons we could learn from the telecommunications industry. So Ma Bell was the monopolistic utility for communications. In 1977, this is what we looked like. We had just these service territories that were all owned by AT&T. So even though they had different geographic service territories, it was one monopoly that owned all communications. Fast forward to 1982, actually, Federal Communications Commission was established as an agency that was going to be regulating the communications market. And they broke it down into what's called baby bells. Each of these entities were now required to be more succinct and address these regional needs. And then we fast forward 10 years to the Telecommunications Act of 1996. This broke open the doors for competition with regards to decentralized communications. It also encouraged all telecommunications to develop new technologies and higher quality services by introducing competition into the marketplace. So what happened when we did that was we had, from 1938, 40 years worth of, quote, innovation, but since it was owned by a monopolistic utility, you see the difference in the technologies. We go from a rotary phone, the only difference is just push buttons. Fast forward to the early 80s, we now see by the late 80s, we have cell phone design. And then fast forward to post-1996, Telecommunications Act, this is the innovation between 1998 through the iPhone in 2007, less than 10 years. So competition can drive this innovation. So where we need to go now is we need to look at how we organize to get from where we are now to where we need to be. Trade associations that represent integrated solutions and a mosaic micro-utility interest. So bundling the opportunities for not only renewable generation, but long-term, short-term storage, microgrid interest, artificial intelligence interest, the services industry. We need something akin to the Telecommunications Act of 1996, because right now, it's like smartphone interest going to Ma Bell and asking permission to compete. You have a company named Sonova that asked for the California Public Utility Commission to grant them micro-utility regulatory designation. And of course, they said no. Why would a utility want to introduce competition to their services? So what we need to do is we need to leapfrog above that and look for legislation on a national level. Something akin to what I pithily called the Eco Energy Act of I don't know what year, because we need to organize that silver buckshot first, but there is no silver bullet. It's not going to be a hydrogen economy. It's not going to be a nuclear economy. It's not going to be one technology. It's going to be myriad technologies working together, cooperatively, collaborating. And that the funding and support for these decentralized approaches, we need to focus on what the economic value is to society and ask the right questions to get the right answers. Set the rules for the market in a way that it will play by them, but the rules actually have to be right. And we need to transform our extractive energy as the economic driver to sustainable and circular systems. And it was 20 minutes, and I told you it's going to be a little bit of an auctioneer presentation. But do I have any questions? Yeah.
This is amazing. One of the things, that Clipchamp was talking about is this idea of developing distributed autonomous systems and networks where there is no profit for environmental protection regulations. In other words, that's the policy.
Mm-hmm.
You put a contract out there and say this is what's going to happen, and you only reward those that fit that. What are you talking about?
So I think that you can piecemeal different approaches, and that is a good part of a piecemeal approach, right? The challenge is we need to change systemically what we're supporting. And so, for example, we talk about carbon taxes, and there's no price on carbon. Carbon is not valuable. We're not paying a price for carbon. Our values are changing as a society as we realize the dangers of climate change, as we realize the dangers that are threatening us by fossil emissions. So the challenge is to set something that is going to change the entire market landscape. And I think we need to prioritize that sort of regulatory reform over, although that is a focal point. In my world, the right question is how do we create frameworks that address the large macro picture? And so even when we're talking about a carbon tax, again, from international competitive perspective, we can't do that just as one country. We have to have global entities that are able to, like the World Trade Organization, that can frame these opportunities in a way that allows all companies, or rather all countries and the companies within them, to agree and cooperate on a more macro perspective, in my opinion.
Take a different tack on it.
Yeah.
Being solar back. Solar, particularly wind also, take up so many square feet per megawatt as compared to a peaker plant. A colleague from Trinity there is speaking of, when you put a peaker plant on a 5-acre parcel, make it fit every day of the week in the middle of town, as long as your USD point sources, but it's an emissions question. That same 5 acres covered with solar is jacked in comparison.
What I'm suggesting is that, and I haven't even gotten into, I could talk for 2 hours about this,
interconnections are the biggest.
Right. And so when you have microgrids and you have this kind of strategy, that would be one of the things that you would access the trillions or billions of dollars, for example, in the Biden infrastructure legislation to try to coordinate ways in which the regulatory framework for microgrid.
Well, everybody keeps talking microgrid, but you got to interconnect.
Right. Well, yeah, exactly. And there are not only that, but you have to have the entities that have the will to want to. And the technology is there. It's the will that needs to happen. I think that because there are companies that are already looking at that as a engineering perspective, and there's a company called they were just brought by Universal Lab or United UL. I can't remember what the acronym stands for, but are doing that work and looking at how you connect the mosaic. There's a company, Billy Parrish started he started as one block off the grid, and now it's called, shoot, Billy Parrish is the CEO. If you Google him, it'll show you the name of the company. But he's looking at the technical aspects of creating that mosaic framework of the grid of microgrids and how you connect those microgrids to one another. The challenge is getting to an economic development framework where we're prioritizing decentralized community development. And I haven't even begun to talk, that's why I could talk for 2 hours. This, when we're talking about a circular economic equation and energy and innovation as the driver, we're also talking about integrating regenerative agriculture. We're also talking about regenerative, other regenerative industries. We're talking about recycling as services, being uber recycling, right? So that it's nothing is wasted. And I know this is idealistic, and I know that it's looking into the future, but Arthur C. Clarke is a science fiction writer. He said magic is only technology that we don't understand yet. There are elements of the natural world and the natural systems that we can learn from, and it's not going to address the engineering question that you have, but looking at how we're prioritizing localized, decentralized economic opportunities with innovation as a driver for that development is where we're not there now, but that's where we need to go. Technologically, though, talk to me afterwards, and I'll look up the latest information. Yeah. So.
In the West, if you look, being from the West, I call it from the Atlantic, you look at, the major freeways and major power line runs, and all the solar development is all along. And you go up to 95.
Well, and this is where my challenge is that everyone has their own silo. Engineers have their own frame of reference. Policymakers have their own frame of reference. Financial folks, investors have their own frame of reference. We need to get everyone cooperating to come up with integrated solutions to this. And there are more and more folks that are using rubrics like circular economic development as the umbrella term for organizing their participation in how this is going to work on a practical level. But it's not just about the technology being developed. It's about innovating those other systems as well. Other questions? Thank you very much. Appreciate it.
Well, that's it. Thanks for coming. I think we have any questions. Good to see you.
Yeah. And now they're seeing people are trying to help with the subsidies that are being requested. I think that all of the fossil subsidies must be removed. And all of those subsidies that were going to fossils need to be allocated to storage and innovation systems. Well, and that's it.
You work with staff?
Yes, Mr.
Yeah. I need to present it next. Can you make sure that my deck is accelerated?
Yeah, let me go ahead. 1 second here.
Yeah, sure.